All right. I'm going to do again another example on case two of the integrals that is needed to be solved using trigonometric substitutions. So I will start with example 4, which says that we integrate 1 over 9 plus x squared, and the whole thing is squared and a dx. So when we know clearly that because of 9 plus x squared, we know that we know that this is actually case 2 because a square is actually 9. It means that a is 3. So our trigonometric substitution is going to be x equals it's going to be x equals 3 times tangent theta. So now anytime we get x, we know we should find a dx. So dx give us 3 secant square theta d theta. And with respect to the right triangle, we can build a right triangle using the trigonometric identity, which is by dividing it by 3, we get tangent theta equals x over 3. So then we know tangent is opposite divided by the adjacent side. Tangent of theta. So we know opposite is x, adjacent is at 3. So by the Pythagorean theorem, we know the hypotenuse is going to be x squared plus 9, and then you take the square root of that. So now we got pretty much everything. So we go to the x integral, and now we're going to do the substitution. So that is the original integral. So we're going to have 1 over 9 plus, now x is at 3 tangent theta. So we're going to square this whole thing. And then dx is 3 secant square theta, d theta. Okay, so we get this. And then we proceed. Now, we have the integral of 1 over 9 plus 9 times tangent square theta squared. Then 3 times 3 secant square theta d theta. So in here, we look at the denominator. We can actually factor out 9 to get 1 plus tangent square theta, and the whole thing is a squared. So, but we know that we use the fact that 1 plus tangent square theta equals secant square theta. So we can replace this by a secant square theta. So therefore, we're getting 1 over 9 times secant square theta, the whole thing is squared. So then we're going to, again, we on a denominator. So what I'm going to do is I'm going to square 9, just distribution of the square. So square 9, but then you write secant square as secant square squared as a secant square times a secant square theta. Why? Because then I want to simplify. So in here, I can simplify. So I can simplify secant square with secant square, and so then when I go to constants, I can pull outside of the integral 3 over 9 times 9. So 9 square is 9 times 9. And then I'm going to have 1 over secant square theta d theta left. Now, I will go to here and basically simplify. So 3 by 3 is 1. 9 by 3 divided by 3 is 3. So I will end up with this new constant. So 3 times 9 is 27. And then I'm going to use the fact that 1 over secant theta is basically cosine theta. So hence I am then integrating cosine square theta d theta. And so here again, to integrate it, since cosine has a degree 2, we can't just integrate that. So we need to use the double angle formula, which says cosine square theta equals 1 plus cosine of 2 theta all divided by 2. So that's a double angle formula. So I will then integrate 1 plus cosine of 2 theta all divided by 2 and then d theta. 2 is a constant, so I can bring 2 outside, which makes this, 1/2 outside, which makes 1 over 7 times 1 over 2. And now I will integrate 1 plus cosine at 2 theta. So I get 1 over 54. So now when I integrate 1, I get theta. When I integrate cosine 2 theta, I will get sine 2 theta divided by 2, and then plus c. So here we're going to work on this. So to simplify this, I will use a double angle formula that says sine of 2 theta is a 2 sine theta times cosine theta. So I can replace sine 2 theta by 2 sine theta cosine theta all divided by 2. Let's see. So hence, so now I can see that I can actually simplify the 2's and be able to collect what I have. So you get 1 over 54 times sine theta and then times cosine theta plus c. So now I'm going to go back to my trigonometric substitution, which says that we have this triangle. So all I need to do is find sine and cosine from here. So from this trigonometric, from this right triangle, I will then find sine theta. So I know sine theta is going to be x over square root of x squared plus 9. And then cosine theta is going to be 3 over square root of x squared plus 9. So, respect to that, I get, so sine theta equals, and then cosine theta equals, go back to here. So sine theta is, again, x over a square root of x squared plus 9. So it's x over square root of x squared plus 9. And then from, again, going back to that right triangle, to find cosine theta, I get x over square root of x squared plus 9. So give me, give me 3 over x squared plus 9, square root of x squared plus 9. So using these two into my answers, I'm going to get, then, so I'm missing something. Now, since the trigonometric substitution was 3 times tangent theta, then if I divide this by 3, I will get tangent theta, and then I will take the arctangent, to get my theta. So therefore, the answer is arctangent of x over 3, which is theta, plus x over x squared plus 9 square root, and then times, then cosine is at 3 over x squared plus 9, and then square root of that, and then plus c. Now we can see that this can be, we can play with this a little bit before we stop. So we multiply the numerators. The denominator, since they have the square root, when you multiply square root of x squared plus 9 times itself, you get x squared plus 9, and then plus c. So that gave us the answer that we were looking for. Thank you.